Hi all. Welcome to .NET Application Deployment on the on-prem Kubernetes using Helm demo. In this video, we are going to demonstrate the deployment of .NET applications on the on-prem Kubernetes cluster using Helm. The complete process is orchestrated through the Jenkins pipeline. The tools which are used in this .NET application deployment are GitLab for source code management, Jenkins for continuous integration. MS Build is used to build the .NET source code. SonarQube for code quality checks. JFrog for Artifactory management and Docker image registry. Kubernetes for container orchestration. Helm for Kubernetes package management. Docker for containerization. Let's explore the workflow of .NET application deployment on Kubernetes using Helm, stage by stage. Jenkins job will pull the .NET application source code from GitLab. A webhook is configured on GitLab so that the ongoing deployment job will trigger automatically when a commit happens on a particular branch. In the next stage, the .NET application source code will be built using the MS Build plugin on Jenkins Windows Slave. In case any failures in the build step, pipeline will be aborted. The deployment package will be archived on Jenkins for future use. In this next stage, Jenkins uses the SonarQube scanner plugin for continuous inspection of code quality to perform automatic reviews with static analysis of code to detect bugs, code smells, and security vulnerabilities. SonarQube offers reports on duplicated code, coding standards, unit tests, code coverage, code complexity, comments, bugs, and security vulnerabilities. When the code doesn't meet the quality standards, an alert mail will be triggered to the development team, and the pipeline will be aborted. Once the code meets the quality standard, the archived .NET application package will be pushed to the JFrog Artifactory repository. The Docker image will be built using the Docker file and pushed to the JFrog container registry. In the final stage, Jenkins will deploy the application using the Helm chart, which will perform the below tasks. Create a deployment on the on-prem Kubernetes cluster, which will create a replica set, which in turn create the pods using images from the JFrog container registry. The .NET deployment will be exposed as an external service, which in turn uses MetalPound to provision a layer 4 load balancer and expose the application on the predefined IP address. Now, let us see how the continuous integration and continuous deployment of the .NET application happen via the Jenkins pipeline. Let us trigger the Jenkins pipeline for .NET application deployment. In the first stage, the Jenkins pipeline job is preparing the repo and git config. In the next stage, the Jenkins pipeline job is pulling the source code from GitLab, which contains the .NET application source code, Docker file, and Kubernetes Helm chart. In the next stage, the Jenkins pipeline job will build the .NET source code in Jenkins Windows Slave, based on the target operating system. In the next stage, SonarQube analysis is getting executed, and it is validated against the quality gate. As the quality gate is passed, the Jenkins pipeline is pushing the built binary package to JFrog Artifactory, then the Docker image will be built using Docker file, and pushed to the JFrog container registry. In the final stage of deployment, the Jenkins pipeline job will deploy the container, and expose the application via MetalPound load balancer, on the on-prem Kubernetes cluster using the Helm chart from Git. Now, the deployment has been completed. Let us check the load balancer IP address for the application. We can access this load balancer IP address in the browser, and this is the .NET application that was deployed on the on-prem Kubernetes cluster. Let us see the continuous integration and continuous deployment in action. As a developer, let me make a visible change in the source code via GitLab UI and see how the changes are automatically deployed into the servers. Here, I am changing the heading in the application, which should be visible in the application after the automated deployment. Let's commit the changes. Let's see how the Jenkins pipeline job has been triggered automatically via a webhook as the administrator user. The pipeline is getting completed. Now the changes should be updated. Let us refresh the web page. This is the complete workflow.NET application deployment on the on-prem Kubernetes Helm. For more information, please browse www.zippyapps.com. Please follow us on social media, Links are available in the description. Like, share, and comment on this video. Subscribe to our channel for the latest happenings on DevOps. Thank you for watching this video.